Hello all, welcome to Code Hub. Today let us solve the Read Codes daily challenge, and the problem is 2 sum 4 input is a BST. Given the root of binary search tree and a target number k, return true if there exist two elements in the BST such that their sum is equal to the given target. So the problem is they have given a tree. We have to find given a binary search tree, return the true if there is exist two elements in the BST such that their sum is equal to given target. So we have to find whether there are exist any two elements that sums up to given target, which is k. So if the k is 9, we can find our two elements 6 and 3, so which is 9, so we can return true. For this tree, if we can form two elements that sum up to 28, we can return true, but we cannot form any two elements, so we have to return false. So what will be the brute force for this solution? So the brute force will be we can do an in-order traversal and store the elements in the order, store the elements in a vector. So what does this do? Since it is a binary search tree BST, this will store in ascending order. So obviously the elements are in sorted order. After the elements are in sorted order, what we can do is we can apply a two sum technique, that is 2 3 4 5 6 7. So this is the vector we will be getting, and we can apply a two pointer technique. We can have a I pointer here and a j pointer at last. If we can see whether this 2 plus 7 is forming a target. If it is forming the target, then we can return true. Else if the sum is greater than the target, then we can decrement j pointer, else we can increment our I pointer. So this will be our brute force solution. Obviously this will get accepted, but how can we do this problem without an extra space? That is going to be a tricky part. So since it is a binary search tree, can we apply this same two pointer technique in this binary search tree? If we can apply this technique in this tree, then we are not going to use any extra space, and we can solve this problem with an order of one extra space. But how we can do that? That is what we are going to see here. So how we are going to apply this two pointer technique I and j in this tree? For this you have to know about the BSTIterator as a prerequisite, but I will do the code with using this BSTIterator. What does this is going to do is whenever how we are getting this I and j using this two pointers using in a vector. Likewise, this BST iterator is going to help us to give the give the left node and give the right node whenever I call this left and right. And if I ask the what is the next node, then what is the next node, then it will give it as 3. Similarly, from this right, what will be the next node? That is going to be 6. If I again call this next node, it is going to give us 5. And if I again call this next node, it is going to give us 4. And if I again call this next node, it is going to give 3. And again when I call this next node, I am going to give us 2. So I'm actually implementing this two pointer technique in the tree BST. Let us say as BST. So for that we are in need of an I and j pointer, but we cannot easily access as like in vector. So for to make use of that, I'm going to use this BST iterator. BST iterator is nothing but whenever I call this I of next, the next method when I call, it is going to give the next node, and this I is going to give us in sorted order. I iterator gives the node in sorted order for each call. each call. Similarly, the J iterator is what it is going to give us. It is going to give us a node, but it reverse sorted order. That's it. Why this is true? Because the BST, whenever we are doing an in-order traversal, it is going to give us a sorted order only. So hope I make sense are we using this BSTIterator, but the implementation, let us see one by one. So let us first see the iterator that is going to push in sorted order. So this iterator is going to give us a node for when each time I call this next function. So the next function is going to give us the next node. So there are going to several functions in this BSTIterator. I will implement it as a class. So what I am going to do is I am going to make use of a stack here. Why the stack is whenever I have given a tree, I will start push the nodes and I will start pushing the nodes till the left exhaust. So what I will do is this is consider this is my stack, and I have pushed this root of the tree 5 and I'm going to its left, and left of the tree is left node of the 5 is 3, and I will go to its left. The left node of the 3 is 2, and I have pushed this push the nodes in my tree, in my stack. So we have inserted all the nodes from the left subtree or left nodes in the stack. Now when I call the next, what I will do is, when I call the next, this next is going to give me the node 2, and when I take this top of this node, I will insert the right and all its left into the stack, but there is no right to its node 2, so I will pop it out. Now when I call again this next, what it will give is, it will give the node 3, but whenever I call this get this node 3, I will go to its right and push all the left nodes again blindly. But since there is no left for this 4, for this node 4, what I will do is I will again proceed further. Whenever I call again, consider I'm calling the next function. Whenever I call this next function, this next function is going to give the node 4, and when since there is no right for 4, there is no function is going to happen. Now whenever I call this again, this next function, it is going to return as 5, and whenever it is returning this 5, I'm going to insert the right node into the stack and all its left. Since there is no left nodes here for its this 6, what I will do is I will just insert 6 into the stack. Now again, consider I'm calling the next function. So when I call this next function, I will pop this 6, and this 6 is my next node, and the right of 6 is 7, and that is inserted into the stack. So hope you get this algorithm. And again, consider I'm calling this next function. The node is 7, the node I get is 7. So so in a tree I can use this BSTIterator using a stack to get the next node. Similarly, if I do this in opposite fashion, for this getting the right node first, what I will do is, so consider now I am getting the ith iterator, getting the jth iterator nodes. So whenever I call this jth iterator, what I will do is I'm going to maintain the stack, right? First I will push all the nodes to its nodes that are in right, 5, 6 and 7. So that is all pushed. So whenever I call this next function, what I will do is I will get the top of the top node as the next node. Whenever I pop out this node, I am going to push the left, push the node left, and I'm going to its right. Since there is no left node for this 7, I'm leaving this as such, and I'm again calling this next function. So whenever this 6 is called, so it will go to its 6 left, but there is no left for 6, so that is left again. Now when again I'm considering I'm calling the next function, so I will get this 5. So whenever I pop out this pop out 5, I will go to its left node, which is 3. So 3 is inserted. Once the in 3 once I'm going to its left, I will go and push all the nodes to its right again. So what I will do is I will put 4. That's it. These are the nodes that are to its right. So now when I call the next iterator, next function, 4 is given, and there is no left for this 4, and it is proceeded further. Whenever I call this next function, 3 is returned, and 3 is popped. Whenever this it is popped, I will go and push the node to its left, and I will go till its right, but there is no right for this 2. So that's it. So whenever I call this next function, 2 is returned. So through this iterator, I can traverse the node one at a time. So that is what we are doing. Doing here. So instead of using an extra space, we are using this BST iterator to traverse it. So for that, what I can do is first we can define a class BSTIterator. So in this BSTIterator, what I'm going to do is I'm going to have some functions. What functions? Let me call this function to be push. So this is going to be a void function. So this is going to be a void function where whenever I call this push function with tree node star root. First of all, what I'm going to do in this push function is I'm going to push the node for push the all left nodes if it is a it is an ith iterator. If it is a jth iterator, I'm going to push all its right nodes. So for to know whether it is an ith iterator or jth iterator, what we can do is we can have a boolean variable boolean flag, which is going to denote whether this is an this is going from left to right or right to left. So this is my flag variable, and I can also have a constructor. I can also have a constructor BSTIterator. This constructor is going to going to initialize this flag to be true. Or else instead of having a flag here, what we can do is we can pass this flag as a parameter itself. So that will be more easier, right? So whether it is a left to right, we can just pass a flag and say. So if my flag is going to be true, if my flag is true, what I'm going to say is this is going from left to right. Left to right in the sense ith iterator. So else it is jth iterator. So this is coming from right to left, and this is some jth iterator. So if my flag is true, what I'm going to push is st dot push off stack dot push off. First I will take a copy of this root. So tree node star equal to root. So what I'm going to do is I'm going to its left node while my curve is present. I'm going inside this loop and push st dot push off curve of curve. I'm going to put curve, and I'm going to go to its left, curve equal to curve of left. So the same thing happens. So what we can do is we can do like this. While my curve is present, I will push that curve into my stack, and if my flag is true, if my flag is true, then I will make cur equal to cur of left, else cur equal to cur of right. So hope this looks good instead of writing like that. So we have written the push function. So this push function will do its job, what we are expecting. So next what we can do is, now we can write the function for next. So the next, what does this next is going to do is, it is going to return me an integer variable whenever I call this into next. So if I call this next function using this, I am passing this tree node star root. So similarly I should have a boolean flag variable as well. So I will take a copy of the tree first, cur equal to root. Okay. So now what I have to do is, I should take the top node. So what I can do is, if my stack is empty, whether the node's value is negative, yeah, the node's value can be negative. So what we can do is, I can first take the current node auto sorry tree node star cur is equal to st dot top. So I have got the current node, which is the top of the stack, and once I get the current node, what I have to do is, I will take the value. Int val is nothing but my cur of val. So I got this current value also. So now what I can do is, based on the flag, I'm going to go to its left or right. So if my take this, or else we can just call this push function, right? So what I will do is, consider I am at this position. So if I call this next, what it should do is, it should pop the value 3. What I will do, I will just trace it. So now the stack, the nodes in the stack are 5, 3 and 2. Whenever I call this function next, this 2 is eliminated, and 2's right I will go and push. I will call the push function again. So yeah, I got it. So if my cur of right is present based on the flag, if my flag is present, if my flag is true, then if my cur of right is present, if my cur of right is present, what I will do is, I will call this push function, push cur of right with this flag. Else if my flag is false, then I am coming from right to left, that is the jth iterator, and I will want to go to its cur of left, and if my cur of left is present, I will call this push function again, push function cur of left flag. So this next function will do its job based on the flag given. So this is the BSTIterator that we are going to do, but we have not yet declared the stack for it. We can declare a private stack with this of type tree node star, which is st, and we can create an object for this BSTIterator individually for its left to right and for its right to right left. So now our job is done for these two functions. Now what I can do is, I can have a BSTIterator. I will name this to be left to right. I will name this to be ith pointer itself, so that it will be easy. As we know the two pointer approach, I am going to access it as j as such. So whenever I call this BSTIterator I, and there is another object of j. So now what I can do is, first initially I can push I dot push off root. Initially I can call this function I dot push off root, and similarly j dot push off root. So what will be the base condition? So first we are going to push the node, right? The parameters that are passed are root and flag. So I dot push off root comma true, and similarly this is comma false, because based on that we have going left to right and right to left. So what will be the base condition? The base condition is nothing but the same thing that applies here. I will get the int left val is nothing but I dot next of I dot next val I dot next. I should pass the root. Sorry, I don't want to pass this root at all. I can just pass this flag variable here, because I am taking the root which is the stack dot top, right? So I can just pass the flag variable. So here true, and int right val which is nothing but j dot next of false. So while my left val is less than my right val, I am going inside this loop, and at the end of the day, if I cannot make this target sum, I will return false. And now I will calculate the sum. Sum is nothing but my left val plus my right val, and I have to check whether my sum is equal to k. If it is equal, then we can just return true. If not, I have to decide whether I should move my I pointer or j pointer. So similarly to the two sum in our vector. So if my sum is greater than k, what I should do is I should move my j pointer. So I should decrement j minus minus. Instead of doing the j minus minus only, what I will do is I will calculate the right value as nothing but j dot next of false. Else if my sum is lesser than k, I will update my left val which is nothing but I dot next of false, next of true, sorry. And until this we are going to do this loop, and if I get it, if I didn't get this true at all, I will get false. So hope this should fine. So let us try to run the code and see. Should get accepted. Oh sorry, I didn't return any val. So return val, that's it. Oh god, time limit exceeded. Okay, let us analyze what is the thing is happening here. Yeah, actually I didn't pop the element, right? Stack dot pop. That should happen in our next function. So the next function takes the top element and then it will be inserting other values. So we got accepted. Let us try to submit the code. Superb, it gets accepted. Hope you like this solution and let me know in the comments. So I have live coded it, the solution also to my knowledge of this BSTIterator. If there are any problems you face, you go back and see. So this BSTIterator, this function is nothing but we are just having a push function, and this we are next function. This next function is going to give the next node according to the left to right or right to left, and this push function is going to push the nodes based on the flag variable. That's it. So let us see in tomorrow's LeetCode daily challenge. Until then, bye.